session. Today we would be understanding the concept of continental drift, that is one of the most important theories related to the origin of Earth. However, this was later on considered as a kind of invalid theory, and the most recent theory which is accepted is the plate tectonics theory. The continental drift theory was initially propounded by Abraham Ortelius, a kind of very rarely known name when we talk about continental drift. However, the main theory was propounded by Wegener in 1912, and the English version of this was translated in 1924. Later on, plate tectonics, as I said, was adopted as the most acceptable theory in the field of origin of Earth. Now, there was a question how continents evolved over time. So, there could be kind of two aspects that led to that could explain why the climatic conditions of the continent vary over time as well as over the region. So when we try to explain that, scientists came up with two fundamental concepts. The first was the climate zones remain stationary. That means if I talk about the North American landmass, I could say that the climatic zone of this region remained stationary, but this continent itself moved. As a result, over time there was change in the climatic conditions found in this region. The next aspect talked about movement of climatic zones. So it said the continent remained where it was, but the kind of climate zone that existed in that region shifted. So there were two theories there were two ideas basically we could say that could explain how there was a change in the climatic conditions of a region. So some of the followers believed that continents remained stationary, the other followers believed the climate zones remained stationary. What Wegener believed was that climate zones remain stationary while the continents move, and this was one of the reasons or one of the explanations that led to the development of this theory. So when we talk about Wegener's theory, he explained 5 evidences that could support his idea, his basic idea why climate zones were stationary. So to support the idea, he gave 5 different kind of explanations. The first explanation was the jigsaw pattern, or the pattern that one continent fits into another. So you have the South American continent here and the African continent here. What Wegener believed was, under the present day world, we can see you have Atlantic Ocean here, but what he believed was, initially you could see that South American continent perfectly fits up with the African continent, and he explained that this could have been a kind of single landmass during some point of time. The next evidence that explained Wegener's theory was the similarity in the fossils that were found over the various regions. So he said the fossils of Cygnognathus were found in South American and African region, which if we try to merge those continents, they form a common belt. The next was another land reptile which was found in African, Indian as well as Antarctic continent, and that was Lithosaurus. You had similar remains of Mesosaurus in South America and South African region, and then you had similar fossils of Glossopteris, which are common in Australia, Antarctica, India, Africa and South America. So these were some of the fossil evidences that suggested that these landmass at some point of time were together. So the first evidence that we talked about was the fit of continents, or I could say the jigsaw pattern. The next evidence was the fossils. The third evidence was similarity in the rock structures. According to Wegener, the rocks of North American region, that is Appalachians, and the the region of Scotland, so you have the Caledonian Mountains here. So these mountain ranges and these mountain ranges were similar in age, rock type and structure. So what he said was the similarity in the rock structures of the Appalachian Mountains and the Caledonian Mountains. The next evidence was the Paleoclimatic Evidence, under which he explained the present day North Europe and Appalachians are rich sources of coal. Coal is a compound that I could say is found in hot, wet equatorial climate. So at some point of time, these regions were located, I could say, at the equatorial zone, and they slowly drifted away from the equatorial area. Similarly, this was considered as the ice covered area or the glacial ice area, and the continents slowly drifted from this area, and you could have Antarctica here in the present day, on the present day globe if we see. So that was the next evidence. The final evidence was the Paleomagnetic Evidence. Now before we understand Paleomagnetic Evidence, let me explain what is the concept of polar wandering. So polar wandering states that the magnetic poles move over time. So there is a shift in the magnetic poles, and all the rocks have magnetic dipoles. So by understanding the structure of rock, we can explain what kind of polar positions the rock had. So over the time, we can say the rocks in this region had different polar positions. Now with every rock, if I see the rock of this region and the rock of this region, I could say they had similar polar positions. But if we see them on the curve, they had a different APWA, that is apparent polar wandering path. So the path for this rock and this rock was different on the present day map, but if I merge the continents together, I could see both the rocks fall under the same polar wandering path. That means at some point of time, these continents were together. So the fifth evidence is paleomagnetic in nature. Based on these 5 evidence, Wegener suggested that definitely there is something that proves that continents have moved over the time period. To explain this, he said, Sial, that's the upper layer, and Sima, that's the lower layer. So he explains Sial moves over Sima and there is no friction. So how did he try to explain the theory? So when he tried to explain his mechanism, he explained that over the time period, as we can see, there was a common landmass that slowly and gradually drifted over time, and this is what we have on the present day Earth. So what he explained was there was a common landmass which was known as Pangaea. This was surrounded by a water body that was known as Panthalassa. Now this Pangaea was found around 225 million years ago, that is during the Carboniferous period. During the Jurassic period, there was a split in Pangaea that was around 170 million years ago, and this split led to formation of Eurasian landmass and Gondwana landmass. So I could say the Eurasian was the northern landmass and Gondwana was the southern landmass, and in between the two you had the Tethys Sea. So there was Tethys Sea that existed between the northern Laurasian landmass and the Gondwana landmass. Then around 140 million years ago, there was a split in the Gondwana land, and this period was the kind of early Jurassic period, I could say, early Cretaceous period. Jurassic period, it is split into Eurasian and Gondwana, and under the Cretaceous period, early Cretaceous period, it is split into India, African South America and Antarctica, Australia region. So this region, you had African and South American continents that were together, and Antarctica and Australia, that was common region. Later on, there was a split in the Laurasian landmass, and this was, I could say, during the Cenozoic time period. And this Laurasian mass split into North America and Eurasia. Around 124 million years ago, there was a split between and South America and Africa became separate continents, and here Australia and Antarctica became separate continents. But slowly, South American continent started moving towards north and east around very recent time frames, and this moved close to North America. Similarly, India moved north and collided with the Eurasian continent, and this was around 20 million years ago. So with this mechanism, what Wegener explained was you could see the present day Earth as it really is. But how this process took place? He explained 4 basic ideas to explain this process. The first was the forces that led to drifting. So when he explained the forces that led to possible drifting, he talked about 3 concepts. First was the equatorial drift. The second was the westward drift. And third was the centrifugal pseudoforce. So to explain the equatorial drift, he said that gravity and buoyancy are the main reasons because of which there is equatorial drift, and he explained drifting of equatorial concept by means of Sial floats over Sima. Now you must remember this because later on he tried to give an explanation that was controversial to it. So here he explained that Sial moves over Sima and there is no friction. Then he explained westward movement or westward drift that was due to the tidal forces, and this westward drift was maximum when moon is nearest to earth. The next he explained the centrifugal pseudoforce, where he explained that the continents are pulled apart by the rotation of the earth. So these were the 3 concepts that he took into account to explain the forces that were responsible for this drift. The next was the actual drifting process. As explained previously, he considered this to be a single landmass and which was surrounded by water. Over the time frame, there was Tethys river that flowed between the two, and you had the Eurasian and the Gondwana land. And in the present day map, you could see the Tethys has been is no more, and you have an expanded form of the Atlantic Ocean and the Indian Ocean that exists. So that was the process of actual drifting that we have talked about, was explained under this theory. Now to explain mountain building, he said there are 2 forces that act. One is the westward force and the equatorial force. But when there is a westward force, the continents or the rocks here start to move westward, but there is a resistance that is offered by Sima. Now here he himself brought in a controversy to what he originally said, and he explained that you have Sima here and that offers resistance. As a result, you have crumbling along the edges. This crumbling led to formation of Andes and Rockies here. So that was how he explained the westward location of the mountains. The next he tried to explain the equatorial shift, because of which he explained the mountains or the alpine ranges and the Himalayan ranges, I could say. So he said, due to the equatorial movement, you have mountain ranges over this region. So that was one aspect that he tried to explain how mountain building took place. The next was, he also tried to explain how islands originated. To explain how islands originated, he explained there is differential rate of drift. That means the rate at which the islands are drifting is different. So he said, due to the differential rate of drifting, there is origin of island arcs. He explained this while considering the Asian bloc. He said, while the Asian bloc was moving westward, what happened was the western part of the Asian bloc moved at a faster pace as compared to the eastern part, which lagged behind. As a result, you had formations of island areas of you could say Philippines and Japan on the eastern side of the Asian continent or the Asian bloc. And to explain the islands here, he said the American plate on the western side moved at a differential rate as compared to the eastern side, and you had origin of island groups of West Indies in this region. So he tried to explain the concept of mountain building. He tried to explain the concept of origin of island arcs. He explained what were the forces responsible that led to the drifting of the continents and the formation of the present day world as it appears to be. So based on this, he tried to prove that the original continent was considered to be floating, or the original landmass used to float over a surface over Sima. So that Sial floated over Sima, I could say, and based on which he explained this theory. But later on, when he brought in the concept of mountain building, he said the Sima offers resistance, and as a result there is crumpling on the westward side that leads to formation of mountain. And this became the very first criticism that Wegener had to face for his theory. So the first criticism was the criticism from his theory itself, which was a kind of controversial statement that he put up. So the first criticism was that if you are saying that Sial floats over Sima and there is no friction, you cannot say that Sima offers resistance and that led to the formation of mountain building. The next criticism was the forces explained by Wegener were not sufficient. So the physical forces or the physical processes that were considered by Wegener were not sufficient to explain the process of continental drift. The third was he could explain the fit of South American landmass and African landmass on one side of the Atlantic Ocean, but he could not prove it for the other side of Atlantic Ocean. So that was the next criticism. The next was, if I say gravitational measures can be explained in many areas that are not in isostatic equilibrium, but this was not considered by Wegener. So that was another criticism. Again, he could explain this theory only if he considered that there is something that floats over the that is Sial that floats over the Sima. So there should be something that is fluid below to prove his theory correct. So these were some of the major criticisms that were faced by Wegener. To overcome these criticisms, plate tectonics concept was laid down, and under plate tectonics, what they tried to explain was the crust floats over the mantle, but the crust itself can be classified, I could say, as continental crust and oceanic crust. Now the continental crust, which is much lighter as compared to oceanic crust, and at the oceanic crust you have the spreading areas and the subduction zones. So this we would be covering when we will be talking about plate tectonics, which is the next important theory, or I could say the most popular present day In present day context, we can say plate tectonics is the most popular theory to understand the origin of Earth. So with this we cover what was the Wegener's theory, the basic evidences for the Wegener's theory, how the process of Wegener's theory took place, how what forces he explained, how did he explain the process of mountain building and origin of island arcs. Thank you. You can subscribe to Examrace channel for further updates. Have a good day.